Well, hello everyone, welcome back guys. Hope you all are doing well. This is Mohammad Badrudduja and today we are going to solve a machine from Hackthebox. The machine name is Health. So without wasting time, let's go and we start scanning the machine with the nmap as always. So nmap space hyphen, nmap space hyphen s capital V for version information, space hyphen s capital C for default scripts, and the target IP which is 10.10.11176, and I want to save the scan results in a file named as default.nmap. So to save the time, I already ran the scan, so I will just show you the scan results. Cat default.nmap. So as you can see, there are two ports open and the third port is filtered. Okay, so the ports open here is port number 22, which is TCP port and default for SSH, and the port state is open. The service it's using is OpenSSH 7.6 P1 Ubuntu. This is the operating system, but the service doesn't seems vulnerable. Next port is port number 80. Again, this is a TCP port. The port state is open, and the service here is HTTP service. So port number 80 is default for HTTP service, and the server running here is Apache HTTPD 2.4.29. The title here is HTTP monitoring tool. This is some kind of monitoring tool. Okay, but the port filtered here is port number 3000, which is TCP port, and the service is PPP, and it is filtered. So because this is filtered, we cannot access it. From the outside. So I already open up here port number 80. I visit the website, and here, as you can see, there is health.htb. I already created a record in etc host file. So if I want to access it from the name, we can also access that. So health.htb. And we landed on the same page. Fine. Now what this is doing, as you can read here, simple health check for any URL. Okay, this is a free utility that allows you to remotely check whether an HTTP service is available or not, and it is useful if you want to check whether the server is correctly running or if there are any firewall issue blocking the access. That means whatever service over internet, running over internet, if we want to check whether that service is available or not, working or not, we can check it from here. So what we can do, if it is correct what they mentioned on their website, so if I say python 3 space -m http.server on port number 80. So what I'm going to do, I'm going to publish the HTTP web server, HTTP Python web server on my machine, which is attacker controlled. So, and we want to test whether it is testing right or not, whether this server is alive or not. So we can do it here by configuring the webhook. So here what I can do is http:// let's say my IP is 10.10.14.27. So 10.10.14.27. Okay, and monitored URL is going to be http:// 10.10.14.27, and interval that seems I think second, so we need to put it in the same format. So I'm going to say here how many stars, 4 stars. So 1 second, maybe 1 2 3 4 stars. And then under what circumstances should the webhook be sent? So I will say always and just test that. So before testing it, I'm just going to make it a little bit visible so we can see both of the windows here. So as I click on test, it is going to send, it is going to access that service what we mentioned. And because this server is alive, so it is going to respond, and once it's going to respond, that means this service will say, okay, I get the response from the external service, whatever you want to test, and the host is healthy, means the host is alive. So that is all what it's doing. So as you can see, we get the request, we get a hit from this target IP, and first of all we get the get request, and then there is code 501 unsupported method post, because this server what we published is not supporting the post method, so it is saying unsupported method, and then it is trying to access the post method, but it is unsupported, so 501. Okay, that means if this is the thing, we can actually come to that point. Why this 3000 service running on 3000 port is filtered? This is filtered because no one from the outside can access this service. Okay, but what this service allowing us to do is, from this service we can access that. Like what? Like I will say, okay, whenever any request come to my HTTP server, so my HTTP server is going to redirect that request to where? To this port, for the target machine, because this port is the service running on this port is also on the published on the target server, right? So what we need to do, same like what we did in the outdated machine, we are going to redirect, and for redirection we can come here to the Google, and we just need to type here like Python 3 HTTP redirect. So how do I redirect the request, or simple redirect server in Python? There are a lot of codes there. You can simply redirect, you can simply just copy this redirect.py file. Although we don't need all of these, we just need this one, this code. And as you can see here, this send.response is going to redirect, and redirect where? Redirect to the URL wherever you want to send it. So I just make a little change here. Instead of URL, I imported here sys. If I open this, so I imported here sys, and instead of URL, I just write here the argument. So wherever you want to redirect the request coming from the target, you can just mention that URL as the argument, and it is going to redirect that request to that URL, whatever you mentioned as argument. Fine. So let's go and we just start this server. Okay, I'm going to clear that, and let's see here ++. So I'm gonna say Python 3 redirect.py, and then I have to mention the URL wherever you want to send or redirect the request. So I'm going to redirect the request on this, and this is what this is going to be the target local IP and the port 3000, what we see in the nmap scan. So whenever we get a request, I'm going to listen on netcat space -nlvp on port number, let's say 4444. So this server, this redirect server will run on port number 80, right? So here I will say http:// okay, and here also payload URL is going to be, let's say, 4444. So monitored URL, where monitored URL will be the server which you want to test. So http:// and it is going to be this, which is a redirector server. So whenever it is going to check this resource is going to redirect the request, where it is going to redirect the request on this port, and after that whatever it is going to access, it is going to send that response on this port, because here it is mentioned the payload URL. So on the payload URL, whatever URL we mentioned, it is going to get the response here. So let's just hit enter here, and we are listening on 4444. Now come back here, and we need this, we need that, and we need this one, and here always. So it is going to check this resource. If this resource is alive, so this resource, this HTTP server here is going to receive that request and then redirect that request to here, and whatever response it gets, it is going to send it here, because this one is listening and the payload URL is this. So just test that and go back here. Now as you can see, because monitored URL is set to my PC, because this redirect server is running on port number 80. So this redirect server receive the request from this webhook, and once it gets the request, it is going to redirect the request to this socket, this URL, and this URL is what this URL is actually doing. It is going to access the port number 3000 from the target itself, from the local host IP, and whatever response this URL gives, it is going to show that response here. Fine. Now we need to analyze this, what actually this is all about. So as you can see, we are connected to this and we are getting response from where? From this IP, and this is the target IP. So I'm going to copy this, okay, and I'm going to paste it here in a new file. Paste that. Now it is actually little bit messed up, but we can see. So the first thing here, if we see these are the details for the webhook. This was the monitored URL, and as you can see, the health is up because our HTTP server was working on port number 80. But the thing is here. So if you can see the metadata, so the name is equal to author, okay, and the content is equal to GOGS. And what is GOGS? GOGS stands for Go Git Service. So this is a Git service, open source Git service, I think, which you can publish privately. Okay. And metadata name is equal to description, content, again, GOGS, Git service, a painless self-hosted Git service written in Go language. That's why it is known as Go Git service. Fine. Again, metadata, this is the CSRF token. Okay. Go Git service. Is there somewhere we have version? So if we have version, maybe we can go to search for the public exploits available. Div is equal to ID from where it started. I think There we will find div class container id promo log. This is the image of the logo, and here, there you go. So this is a form, and this is the id, and as you can see, I think this is going to be the post request, because it is a form, and action is going to be on this endpoint, which is url/login. So because this endpoint is login, so I think it is going to be the post request. Yeah, there is post method, and there are input fields. So the first field is hidden, and the field name is CSRF, and this is the value of the CSRF token. Then there is ID is equal to username. So username or email. So this is actually a login page. Input class large, and this is for password, as you can see here, type password. And there /home. Okay, so this is actually login page, and we have a link to register or sign in, register a user. So we can also register a user here. Easy to install, target blank. Again, this is the doc for the installation of Gogs. And here you see the version. So this is the version of Gogs. This belongs to 2014 Gogs version, which is 0.5.5.1010 beta version. Okay. So is there any vulnerability exist? Because it seems like it is the version of year 2014. So I think we should look for in the search exploits, GOGS, and there is both vulnerabilities belongs to SQL injection, label SQL injection, and users/repos. It seems like a parameter, and SQL injection. So let's see. I'm going to say search exploit space -x, and then open this, paste that, hit enter. So there is API version 1 repos search $Q, and then the search query. So actually this endpoint with this parameter Q is vulnerable. So if we scroll down, you can see this CVE found in 2014, and this is the vulnerable code. Once I did that machine, I wasted a lot of time by recognizing exactly the vulnerability, because actually the information here about the vulnerability and where that vulnerability exists is correct, but it is a little bit changed. And if you try to execute this by changing the URL to your target, this is not going to work. Why? You will see that in a minute. So for this, what I'm going to do, I'm going to GitHub Gogs. So go to Gogs, and this is the releases page, because the repository or the server Gogs here belongs to 2014, and it has version 0.5.5, which is old. So as you can see, the latest version is 0.12.10. So okay, 5.5, I think. Let's go to 4, page number 4. Still 0.10, 0.9. Let's see. 7. Last version is 0.6. I think in this we will find 5.9, 0.5.8. This is the version. So click on this version, and I'm going to get the source code from this. So once you click this source code, you will have this zip file. Okay, so I already downloaded to save the time. So here I'm just going to right click and extract here. Yeah, now it's done. So here we have the directory for the repository, and if you go inside this repository and you go to the routers, inside routers you will find the API. So here the endpoint is, where is the endpoint? This one, API repos search.q. So if I go to inside router, if I go to API version 1, here is repos.go and users.go. So first of all, I'm going to open repos.go, and inside repos.go, if we see the function search repos, okay, so it needs 3 arguments. One is queue, UID, and limit. So search repo by name. This is the model. Okay. Here, if we come down and see the source page, function is search repo by name. Okay. So let's try to see that function search repo by name. And the search repo by name function exists in models. So we go back to health directory, gogs, models, there are models, and there is repo.go. So open with mousepad and let's see. So these are the fields. Fine. ID, name, lower name. And if we scroll down, let's see, where is that function? The function name was, come on, search repositories by name. I'm going to copy that, come back here, Control F and paste that, hit enter. There are 2 occurrences. So this is the first one. This is the first one. And if you find here opt keyword, so I'm going to match so let's match this. So this is prevent SQLite, prevent SQL injection. So this was we found from the search exploit. And if you see this one and the code source code we copied from the GitHub, you can see there is a difference. The difference is, if you see this line, opt.keyword is equal to strings dot split opt.keyword, and it is going to actually filter this space sign. Okay, but here it does not mention this one, space. So that means if you are going to inject the SQL injection syntax, this space will not be allowed. So instead of this space, you have to use some alternative for the space, and only then you can get the SQL injection successfully. Okay, so this was the repo. If I go to, let's say, gogs, inside gogs, if I go to routers, API version 1, and if I go to users.go, here also you will see the same thing. Search user function, and it is going to take that from the models. Inside models, it is going to take it from search by name. So if I again go here, come here, models, inside models, if I go to users.go and go down, search user by name, I think. So there you go, search user by name, and the same thing is written here. The same thing is written here. Fine. And if you go up, you will see all the fields are there, and these fields will be exist on the database. So ID, username, in the lower name, full name, emails, password. As you can see, the password is there. So I think more than repo, this this SQL injection by following search by user is going to work more better. So instead of going to repo, I will use this endpoint for the SQL injection. And if you go to users.go, you can see you just need to use Q as the parameter. Fine. And the endpoint will be this root, sorry, not root. The endpoint will be API/v1/users/search, and then this is going to be the parameter. Right, so let's go. We will write some notes here. http:// and health .htb / actually not that, it would be 0.0.1, because on port number 3000 this go get service is running. So API/v1/users/search, and it is going to use the Q parameter, and its value is, let's say, this. Okay, so this time I'm going to use this. Copy that and come back here. Fine. Now come back here and clear that. Clear that and clear that. And now I'm going to find Python 3 redirect.py, and this is going to be our search query with the SQL injection syntax. Okay, and here I'm going to listen again. So nc --nlvp on port number 4444, 4 times 4. So hit enter here, hit enter here. Now this server is running on port number 80, but it's using redirection. So whenever from the target, from this webhook, whenever we got a request here, it is going to redirect that request to this URL, and this URL is following SQL injection syntax. So whatever response is getting by whatever response we get from this URL, we will see that response here. Okay, because we are going to specify this port on the payload URL. So come back here and put this here, put that here, always, and let's test this. So once we test it, we can see here it gets redirection, and we can see here the health is down. The health is down means it is saying that the server is not up but we know that the server is up. This is because maybe this syntax is incorrect, so we need to correct it. So that let's try this. Okay, and hit enter. Here also I'm going to clear that and run this again. Come back here, and again here I'm going to mention here the payload URL, monitored URL, time, and let's say always. Test it one more time, and this time again it's saying down. So let's try something else. So instead of that, let's try this. Hit enter. Enter. Come back here, and let's say test, and well done. So now you can see it's saying the host is up. Fine. But with the host up, it also gets some data, and the data is username, and the username you can see here, Suzanne, and it also provides us the avatar link of the Suzanne, and other fields are like true, okay, true, whatever. So if we come back here, I don't need that. Don't save. Users.go, not this one. This is inside the router. This one. This is the model. So here if we see, we have name. And as you can see, this field must be unique and not equal to null. That means here in this field, you must get the data. Okay, same like here. Okay, avatar link. So this is the avatar link, what we found. And as you can see, this field cannot be null. Okay, there are other fields also like salt, and there is pass WD. So that means in the database, there must be these fields. Okay, these fields must be there in the database. So let's go and we try to weaponize our syntax little bit more. So let's see, now I'm going to test how many number of columns are there, but the problem is here. Problem is here. We cannot use a space. So let's try. Open this, come here, and I'm gonna say SQLi space bypass, bypassing common filters in the ports figure. Okay, this could be good. I don't need that now. Okay, so to bypass space, you can insert inline comment into SQL statement in the same way as for C++ by embedding them between the symbols like this. Okay, that means if you want to put the space, we can put a space. Instead of a space, we can put this. Okay, if you want to see more, to be sure, let's see, injection with no space. So this is a blog. Injection with no space. error, no space. Okay, and function space is equal to this. So that means instead of a space we can try this one. So what we do, space, let's say order by I want to test how many number of columns are returned by the query. So first thing first, let's say one column. So of course at least it is returning one column. So keep in mind, whenever our query result is correct, it is going to show us host is up, health is up. And whenever our query syntax is wrong or the query is wrong, it is going to show us down. So up means correct and down means something wrong. Okay, and here I forget something, which is this. So I'm going to copy that, come back here, close that, clear, and instead of that, let's paste this, hit enter, clear this again, start netcat listener, I don't need that, come here, and so the payload URL is going to be this. This is the target which we want to test the health, and this, once the request reach to this, it is going to redirect on this with this payload. Okay, and test. So once we test, as you can see, the health is up, and we are also getting this data with the username Susan. And you can see the server is base HTTP Python 3.10.8. So that means the query is returning one column. So until we get here down, we need to increase this number of queries. And in that way, we will know that how many number of columns it's returning. But there is another way you can guess. And what is that way? So if we scroll up here in the model, so we can see here all these columns must be inside the database. So if we count all of these, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Up to here 20, 21, 22, 23, 24, 25, 26. So in the database, what I understand, and according to my understanding, in the database, at least these 26 columns should be there. So what I am going to do here, by guessing from there, in the next query, I'm going to test, let's say 26, and let's go, come here, close this, and here instead of 1, I'm going to say 26, hit enter to start the server and restart the listener, go back here and test it again, and wonderful. As you can see, 26 number of columns returned by the query. And to be sure, I'm just going to increase one more column, and if we got here down, that means okay, our query is incorrect. So 27 are not the valid number of columns, that means 26 is the correct. So let's try 27, hit enter and come back here. Okay, test. That means 27 is also correct. Okay, let's try 28. Clear. Let's try 28. Fine. Because what we are checking here is we downloaded this repository from the GitHub, and this is open source. So maybe once it is published and deployed, maybe they increase some number of columns and rows in the database. So it could be there. We need to check that out. Okay, so everything is ready here. Come back here. Come here. Come here. Okay, always test it. And that's perfect. So as you can see, on 28 number of columns, it's saying that the host is down, means our query is incorrect. That means 27 are the valid number of columns returned by the query. So the first thing we got is username, and the username was SUSANNE, Suzanne, I think. Valid number of columns are 27. Fine. Okay, now the thing is, I just show you that to be sure that okay, there is SQL injection and it's working, how it could be worked and how you can exploit the way. There are many more things. We can directly go to see the information schema, what are the databases available there in the database, and in a particular database how many tables are there, and inside a particular table we can also see how many columns are there. But because of short time and I don't want this video to be very long, through some guesses and what we see here, okay, so we can see that there is a password field and there is a salt field. So let's try to find out whether this password field and salt field is there or not, and if it is, let's see if we get password or not. So I'm going to build a query here. It is very much similar to that, so I'm going to copy this and paste it here. So okay, I'm going to use union because that is union based. So union select, and after select, let's say anything integer we can choose, 1, 2, or let's say 1 1 1 1 1. How many? 3, 5 are there, so I'm going to copy that, and 10, 15, 20, 25, 26, 27. Okay, so if we got 27 valid columns and we put here 27 ones, so if that works, then okay, fine, we can go ahead. So let's try that. Hit enter. Okay, test that. Fine. Up means the query is correct. Now let's try to extract number of extract the password. So because this is written in Go and I'm not good at all in Go language, but yeah, I can see the code and I can understand the code. What are the functions there, which is the string and where it's using integer and why it's using a u, and the concept I can understand. There is if else statement, it is everywhere same if there is any loop. Okay, so as you can see here, there is one function which is encoding the password, and this is why I'm trying to extract the password and salt, because the password built here for the user is actually encoded password, and if you want to decode that password, what you need here password and you need salt, and after you get the password and salt, it is going to make it base 64 dot pbkdf2, and it is going to create a SHA-256 password, okay, with the 10,000 rotation maybe. So this is why I'm looking for password and salt. So let's go, we see that. So back to the notes, and here I'm going to update this query a bit. Copy that, come here, paste it. Okay, I was here because I want to see the data type. So I think this data type is, as you can see, this is the string. So any string value we can call in this particular column number 3, or there is one more. But the thing is, in the output, if you see here, in the output you find this column username, and the username is u.name. So u.name is this third column. So in the third column, I'm going to say, let's see, select, instead of space, make sure you have this, select PASSWD and then space, select password from table name, and table name is going to be user. Okay, because if you see here, this is user.go, and the framework is actually, the structure of this framework is actually MVC, model view controller, MVC framework. So whatever models are there, the table name is going to be the same. Okay, in simple cases. So select password from user, because this is, the model name is user.go. Okay, so I'm going to take this, copy that, come back here, clear. Actually it's better to write. So Python 3 redirect.py, and I'm going to paste that here, sorry, Control Shift V. Okay, hit enter, come back here, Control C, clear, and listening on port 444. Here everything is going to be the same always, and just click to test. Fine, so the health is up, but the problem is, you can see the username, before we got here Susan, and we also got the avatar link, but this time we did not get any username. Okay, we can try a star here, select password from because now instead of in the place of username you will get the password, because the column number here is 3. Let's try that. space, and between two spaces I put all. So it is going to select all and copy that. Come here, Control C, Python 3, paste that, hit enter, and come back here. This is the most interesting part of this machine actually. Okay, test it now. Oh, we did a mistake, and the mistake is here. Clear that, start it, and close that. It should be enclosed with the, we did not specify here redirect.py, and that, hit enter. Now we will get the redirected result. So just test that. Okay, and now you can see we found the data. So now this first result is same as before, but here it's added one more column of result, and in the place of username it grabs the password. So this is the password. I'm going to copy it, Control Shift C, and let's say PASSWD password, which is this. Okay, and in the same way let's grab the salt too. So copy that and paste it here. Just here, put here salt, and Control C, come back here, clear, salt, hit enter, and clear that. Test, and Susan, and this is the second column value, and this is the salt. So copy this, come here, let's say salt is going to be that. Fine, so now we have username and we have salt. Go back to the user.go, this model, and here we found, right, the encoded password. Change username, verify, get user, counter user, encoded password, this one. So if we see that closely, encoded password encodes password to safe format. So that means what we got with this password is encoded with this salt. So to decode it, what we need to create it in this format. Bytes, okay, let's see, go to the notes, copy that, and I want to test Q, clear that, echo space -n, and paste that. This is the password I found. Let's say WC space -c, how many characters are there? That seems maybe hexadecimal. Okay, let's go. I'm going to open here CyberChef, and I'm going to paste the password here. Now let's say hex. So from hex I want to change it to plain text, but once we convert it to the plain text, it gets some gibberish. But the thing is, if we see this function, it is also encoded with base 64. So the next thing I'm going to do is base 64, because we are decoding it. Yeah, this one. So this is the base 64 format of the password. I'm going to copy this, and now I'm going to put it here. Password is going to be this. Okay, but this is with the salt, and we already have the salt. So we need to extract the clear text password. So we have salt, we have base 64. Now what we need is, we need new password is equal to this. So I'm going to copy that, put it here, and if we see this, so it is going to be like SHA 256 and then colon 10,000. So 10,000, then salt. So this is the salt, but this salt value must be base 64 encoded, and this is not the base 64 encoded. This is the clear text salt value. So we need to convert it into the base 64. So I'm going to copy that, come back here, let's see, echo space -n, and paste that here. Base 64 space hyphen base 64, not hyphen. We are not going to decode, just base 64 encode, and this is the encoded value of salt. So I can actually say it here, B64 and salt underscore B64. This is the salt value. So now first we need to put this salt value. So copy that and put it here, and then I think colon again, and we can put here password, which is this. So copy that and paste it here. So now this is, I think, the format to the complete hash, and now we can actually crack this hash. I'm confused a bit whether there should be colon or slash. Let's go to hashcat wiki example hashes. Yeah, this one. So Control F, and I'm going to search SHA 256 colon 10,000. Yeah, 10,000. And as you can see here, PKDF2 SHA 256 HMAC, and this is the format. So this is the salt, the first one is the salt, and then colon, and then this is the password. So this is the code for this hash. So the first thing first, I'm going to copy this, and let's create one new tab here, paste that, save it, and I'm going to save it, let's say pass pass hash hash dot text. Okay, back to the terminal, clear that, hashcat space -m 10900, I think. What was that? The code 10900, yeah. Space pass hash dot text. This is the hash file, and user share word list rockyou.txt. Hit enter, let it work, and I'll be back once it's finished. Actually, it's saying finished because I already cracked that password once. So now it's saying just use -- show. So instead of this word list, I'm going to say -- show. And yeah, so the password here is this, February 15. So I'm going to copy that, come back here in the notes. So finally the username is going to be SUSANNE. We will try with that. And the password we will try is going to be February 15. Save that. On the target we already have port SSH open, so I'm going to clear it, and SSH SUSANNE Susan at health.htb, and paste the password. Boom, we logged in. So if I say ls space -la, and there is user.txt, so let's clear that, and cat users.txt. So this is the user flag. So that's it for this video, and this is the part 1. If you like the content, please like, subscribe and share, and I'm going to see you in the next part number 2, where I'm going to escalate privileges from this Susan user to the root user. Because if I say here grep password, not password, if I say /bin/bash, how many users those can run bin bash in etc/passwd file. So you can see there are gox user, Susan user and root user. Now the thing is, we don't need to go back to the gox user, because Susan user is superior than the gox user. Now the only thing rest is root. So I'm going to see you in the next part in the root. See you. Bye.